In related rates problems, we use implicit differentiation to find the rate at which a certain quantity is changing relative to the known rate of change of another quantity. The easiest way to explain this concept is just to jump right into an example. Let's say that I have a cylindrical tank filled with water, and its radius is 20 centimeters. When the water is being drained at 25 centimeters cubed per second, how fast is the height of the water changing? Our first step is to determine our variables. Now I need to identify what we're given and what we're solving for. What we already know is that the radius is 20 centimeters, and that at the instant we're looking at, dV dt is negative 25 centimeters cubed per second, because the volume in the cylinder is changing negatively as the water is drained. What we're solving for is how fast the height of the water is changing, and that's just dH dt. Now that we have our variables and givens all figured out, we need to identify an equation that relates volume, which we know the rate of change of, to height, which we're solving for the rate of change of. We can just use the equation for a cylinder's volume, V equals pi r squared h. Let's take the derivative of this equation with respect to time. Remember that the radius of the cylinder never changes, so we can treat it as a constant. Plugging in what we already know and isolating dH dt, we find that the height is changing at a rate of negative 1 over 16 pi centimeters per second. If you'd like more explanation or to see another example of related rates, check out the following page from ck12.org.